Okay, so I'm going to look at a problem I've taken off the NRICH website, System Speak, and I'm going to take you through some of the stages that might be involved in working through the problem. Now, I've not seen this problem before to sort of give an idea of a live sense of problem solving, so we might make mistakes, we might get some dead ends, we might need to take some false turns. So let's just see how the problem evolves. Okay, so the first step in solving any problem is to look at the structure of the problem that I can see. So there are 5 equations and lots of variables. So, right. So, but there are 5 unknowns. A all the way through to E. As I look at these equations, I notice there's a symmetry in terms of the way the variables are laid out, because each A occurs in 2 places, B in 2 places, C in 2 places. So they sort of cycle, they're like a cyclic variables. There's some sort of symmetry which I want to make use of, and the numbers though seem to break this symmetry, because whereas these 4 all increase by 1 each time, the last equation increases by 2. If all of the right-hand sides were 1, in other words, if this 6 was a 5, then I might think that the equations all increase by 1, and looking at differences might help, because I could subtract and I'd find that all the equations differ by 1. But that wouldn't work because of the last one. Okay. So, and in fact, if I then took the first equation away from the 6th equation, I get a difference of plus or minus 5, so again that wouldn't work either. So whilst it looks tempting to take differences, I think that might not work in this case. So we need to find some different way of tackling the problem. Okay. Right, okay, so what are the other things we can do with equations? Well, we can add and subtract equations, but given 2 equalities, we can also divide the 2 equalities. And now I've noticed that if I divide the first pair of equations, the B will cancel out, giving me A over C. I can do the same thing with the next equation, and then so on, and then I see that, yes, what do you think? Aha, right, because there are 5 equations, by the time I get to the last equation, I'm going to have a term involving A squared equals a number, and that's going to tell me what the value of A squared is going to be. Let me write this down to explain what I'm trying to say. Because often when you have an idea, you can sort of explain roughly what's going on in your own mind, but then you need to write down the equations to get that crystallised. Notice that I've taken the ratio of these 2 terms, then times by the last term. Notice that the B's will cancel out, the C's will cancel out, the D's will cancel out, and the E's will cancel out, leaving me with A squared. Just as an aside, notice that if there was an even number of equations, this process wouldn't work, because the last number, the A, would be on the bottom, so it would all just cancel out. So this only works because there are 5 equations. Now then, because I know each of the numerators and denominators, I can put the numbers into those, and I can see there's a strategy now, because that's going to tell me what A squared is going to be equal to. A is going to be plus or minus some number, which I can then use in the first equation to tell me what B must be, and so on all the way down to E. So I think that's going to be the way the solution is going to drop out. So, putting numbers in for these now, I've got my strategy. It says that 1 over 2 times 3 over 4 times 6 equals A squared. So that implies that A squared, therefore A squared is equal to 9 over 4. Aha, right. This gives me confidence because 9 and 4 are both squared numbers, so I can take the square root and get a nice square root. So that, therefore, A is equal to plus or minus 3 over 2. It's always good to stop and pause when you're going through each stage in a problem, and I realise now that I was troubled by the fact that this was a 6 in the bottom equation, because it seemed to break the symmetry of the whole problem. You know, why was a 6 chosen? And I see now that if that wasn't a 6, I wouldn't have had a nice square on this side, okay? So I can see now the reason for the problem having been set up in the way it was. So A is 3 over 2, plus or minus. So that would imply, therefore, B is equal to 1 over A, which equals plus or minus 2 over 3. And that tells me what C is equal to, D equals, and E equals. So I'm going to be able to find all the answers to this problem.